Hello everyone, let's try and solve our next problem. Given a real constant c, the equation x to the 4 equals x minus c squared has 4 real roots, including possible repeated roots. For c is less than or equal to a quarter, c is greater than or equal to negative a quarter and less than or equal to a quarter, c is less than or equal to a quarter, or all values of c. Okay, I'm going to write down the equation first. X to the 4 is equal to x minus c squared. It has 4 real roots, including possible repeated roots for basically what constraints on c do we need, which guarantee 4 real roots. Okay. So it's a 4th degree polynomial in x. So there are 4 roots, but they're not necessarily all real. Now, a 4th degree polynomial, we're not going to be able to use simple things we know about parabolas or sometimes even 3rd degree polynomials. So what is a clever thing to do here? Like I'm trying to debate whether I want to approach this in terms of algebra or in terms of analysis. We could start by taking square roots of both sides and then just keeping track of things being positive and negative and so on and see what we come to in that way. Maybe that's what I'll do. It might be a little bit messy trying to keep track of, like when I take a square root here of both sides, here's what I'll do. Okay, I'm going to write this as 2 different equations. This is true. The first equation is true if either x squared is equal to x minus c or x squared is equal to c minus x. If this is true, then this is true. And if this is true, then this is true. Okay, so now I want this to have 2 real roots, and I want this to have 2 real roots. But now that we have a 2nd order polynomial, we should be able to just use standard analysis of the discriminant or something like that. Okay, so let's start with the first case. X squared minus x plus c is equal to 0. So I can write out the roots of this using the quadratic formula. Okay, so I require c to be less than a quarter for this to have 2 roots. Now we'll look at the 2nd equation. Okay, in order for the 2nd equation to have 2 roots, I require c to be greater than negative 1 over 4. Okay, so if I put this all together now, my original equation is equivalent to either this being true or this being true. So in order for my original equation to have 4 real roots, possibly repeated, I need this to have 2 real roots, possibly repeated, and I need this to have 2 real roots, possibly repeated. And I don't even care if the roots of different equations coincide with each other. But for this to have 2 roots, I've derived a condition on c, and for that to have 2 roots, I've derived a condition on c, and I need both of these conditions to be true simultaneously. So this means the answer is B, that the constant c is between negative 1 over 4 and positive 1 over 4. Yeah, I didn't see this approach originally. I don't know why exactly. If the exponents here were anything slightly different, this might have been a lot more difficult. But I suppose the most important part of this question was realizing you can take square roots of both sides of this, but then you just have to keep track of the change of sign of things as you as you square something. Yeah, I'm not sure if I have more to say about this right now, but if I end up with having more to say, or if I find a mistake, then I'll be sure and put it into the description of the video. Thanks for watching.